Welcome everyone to the Unit 4 Study Guide review video. I'm going to go through every question on the study guide. So let's dive right in. In each table, X represents the input value and Y represents the output value. Which table does not represent a function of X? How do you know? You must explain to receive full credit. So the question, just like this on the test, instead of saying input and output, it says X and Y, which is really where this language comes from. We have 4 tables, and one of them is not a function, 3 of them are. So you're supposed to circle the one that's not a function and explain. Okay? Alright, so look at the first one. We input 53, we output 53. Input 26, output 26, input 37, output 37. Okay, so this is a scenario where you input something, and then the output is exactly what you input. So the input and the output are the same. So when we consider what it means to be a function, we say, right, for each input, is there only one output? Or if I tell you the input, can you tell me the only one output that goes with this? So any input I could come up with, like 18, if I input out 18, I know that the only output's going to be 18. Input 53, only output's going to be 53. So this is a function. Each input has exactly one output. And that's the definition of a function. Okay, then we can go on to B. When I input 3, I output 1. But when I input 3, I also output 2. When I input 3, I also output 3. And 3 also goes to 4. Okay, so this is not a function because the input 3 has multiple different outputs. Each input can only have one output. Here, we can input letters and we can output the number 5. This is a weird table, a weird input-output table, but I input A, I just get an output of 5. Input B, I just get an output of 5. C, just an output of 5. Each input has just one corresponding output, so that's a function. And this one, each input has just one corresponding output. Again, 10 only gives me 15, 20 only gives me 45, so that is also a function. Okay. So this explanation that the input of 3 has multiple different outputs, thus it's not a function. The graph shows the temperature in Maya's house between noon, and midnight one day. Select all true statements. A, the temperature was 70 degrees twice during the 12-hour period. B, the lowest temperature occurred between 11 and 12. C, there was a 1-hour period during which the temperature did not change. And D, the temperature was decreasing between 4 p.m. and 5 p.m. Okay, so let's go one by one. We're selecting all the true statements. The temperature was 70 degrees twice during the 12-hour period. Okay, so here's 70 degrees. It is right there. So first of all, at hour 0, at noon, we're starting at 70 degrees. So that's once, that's our initial value. It starts at 70 degrees. Then if we just kind of draw a straight line across, let's see if we get there anywhere else. Yep, then it appears here at hour 10, we're also at 70 degrees. So the temperature increases, more than 70, decreases, stays flat for a bit, and then decreases again and hits 70 at hour 10. So this is true. Right, it is 70 degrees at noon and at 10 p.m. Cool. B, the lowest temperature occurred between 11 and 12. Okay, so we look at our graph and we see here is 11 and 12. Is that the lowest temperature? So is this section, this is like maybe 68 degrees or so. Is that lower than it was at any other point along this journey? And yes, it is. That's the lowest it is. So, yep, that was the lowest temperature was in between that period. C, there was a 1-hour period during which the temperature did not change. Yeah, so that's also true, and that's between 11 and 12. So this is a 1-hour constant period or interval. Okay, there's also this 4-hour constant interval, but there is some 1-hour interval during which we have a constant, the temperature isn't changing, so that's also true. And finally, the temperature was decreasing between 4 p.m. and 5 p.m. So here's 4 p.m., here's 5 p.m., this section right here, decreasing. Oh, look, they're all true. All right, cool. Question 3. A toddler today has a height of 32 inches. They will grow 5 inches this year, 4 inches the next year, 3 inches the year after that, and then 1 inch every year until they stop growing. Is the height of the toddler a function of the number of years? If so, is it a linear or non-linear function? Okay, so is the height a function of the years? So if we think about making a table for this, years is my input, height is my output. If I say 0 years from right now, then we know that the height of the toddler is 32 inches. Okay, 1 year from now, they're going to grow 5 inches. So then they would be 37 inches tall. 2 years later, the next year after that, year 2, we would add 4 more inches and we get 41 inches tall. Then after another year, we're adding 3 inches, then that becomes 44. And then after another year, we're just adding 1 inch, and they're 45 inches tall. We can continue that until we have to know when they stop growing. But for each of these years, I could input how many years it's been since today, and I could output the height that this toddler is going to be at that point. So this is a function, okay? Each year corresponds with one height that the toddler is at that point. It's a little confusing because there might be like, during the year they're growing, but we're kind of like checking in at this year mark. Okay, so yes, the height of the toddler is a function of years. Because each year corresponds with one height. So I could input a year and you could output the one height that the toddler is at that year. Okay, that's question 1. Yes, it's a function. Then we say, if so, is it a linear or nonlinear function? So a linear function is going to have a constant rate of change. So they're going to be growing at the same rate each year. So like every year they grow 2 inches. Every year they grow 3 inches. Here we don't have that. First we grow 5 inches, then we grow 4 inches, then we grow 3, then we grow 1. This is not a constant rate of change, so it is a nonlinear function. And if we did have a constant rate of change, then it would be a linear function. Okay, but there's not a constant rate of change, it's a nonlinear function. Beautiful, so it says explain. You gotta explain that in sentences. All right, moving on to question 4. Itzel goes climbing up a mountain. The graph shows her time and height throughout the climb. What is her fastest speed in meters per minute? So we have minutes here, height in meters there as the output, and we want to find her speed. So our speed in meters per minute is our rate of change. It is the slope of any section of the line, right? So from here, from 0 to 10 minutes, 0 to 2 minutes, in 2 minutes, she's going 10 meters. So the speed for that section is 10 meters per 2 minutes, which is 5 meters per minute. Okay, so that's like interval A, right? Interval B, she's going 0 meters per minute. The slope is 0. It's horizontal, it's constant. She's not going up the mountain, she takes a break. Interval C is here. Okay, we can see that in this time, she's going from 10 meters to 30 meters. That's 20 meters in 2 minutes. So 20 meters in 2 minutes, 10 meters per minute. And section D here, there she's going down the mountain. We can still figure out her speed if we want to. She's going down 5 meters in 2 minutes. So the slope would be negative 2.5 meters per minute. Again, the negative referring to the fact that she's going down the mountain, decreasing there. And then the graph's constant per minute. Okay, honestly, all of that work that I just did was not really necessary. All we needed to do is look at the interval of the graph where the line is the steepest, or the line segment is the steepest, because that's going to tell us the speed. So if you want to do the work to calculate it all to be sure, you can do that. But if you can eyeball it, I can eyeball it and say, like, this section is steeper than this section. And obviously it's steeper than the constant parts. And here, so A is 5 meters per minute, C is 10 meters per minute. So she's going the fastest in interval C. Her speed is 10 meters per minute. Okay, because that's where the line is the steepest. So we have the greatest rate of slope, which is the speed here. Cool. At a gym, the cost of a gym each month could be described as a function of the number of exercise classes a person attends. Is the cost of a gym a linear or nonlinear function? Explain your reasoning. Okay, so we want to see if there's a constant rate of change. Again, if we have a constant rate of change, we have a linear function. If we don't have a constant rate of change, then we don't have a linear function. So here, we're adding 2 exercise classes, and the cost is going up $6. Here, we're adding 2 more exercise classes, and the cost is going up $4. And here, 4 exercise classes, it goes up $15. So if we find those different rates, here, this is a change of $6 per 2 classes. That's $3 per class. Here, we're changing $4 for 2 classes. That's $2 per class. And here, it's $15 for 4 classes, which is $3.75 per class. Okay, so is that a constant rate of change? No, it's not. So this is a nonlinear function because there is not a constant rate of change. And that is the description that we need. A nonlinear function. There's not a constant rate of change. Cool. All right, number 6, Julian began completing the table below to represent a particular linear function. Write an equation to represent the function he was using and then complete the table for him. Okay, so we write an equation of a line. We're going to have y is equal to my rate of change plus x times x, plus the initial value. This is our y equals mx plus b. All right, so let's find the initial value. This should be easy from the table. We look at it, our initial value is the output when the input is 0. Okay, so we look at our graph or our table, we find our input of 0 and our output is -1. So our initial value is our output, -1, when my input is 0. Okay, we also find the rate of change. So the rate of change is how much x is increasing by. When x increases by 1, how much y increases by. It's our slope. Change in y divided by our change in x. So we don't have just like a change of 1 that we know, so we'll have to look here. and here, or we could go there and there if we wanted. But here our x is going from 0 to 3. So we're changing by 3 on the x, and then we're going from -1 to 11 on the y. That's adding 12. -1 plus 12 is 11. So we have a change of 12 in our y when x changes by 3. 12 divided by 3 is 4. So our rate of change is 4. That means that when x increases by 1 here, then y should be increasing by 4. So -1 plus 4 is 3. And then again, x increases by 1. So add 4, and we get 7. And then you can check this, add 1 to 3, you'd add 4, and you'd get 11. Okay, we can also work backwards. So what plus 4 equals -1? That would be -5. And then finally here we're adding a half. So our rate of change, we're going to add, instead of adding 4, we're going to add half of a 4, which is 2. So we add 2, and we get 1. Okay, so filling out the table can be tricky. We really have to use our rate of change and kind of understand that when x increases by 1, y increases by 4. So when x increases by 2, y is going to increase by 8. When x is going to increase by half, y is going to increase by 2, because these are all equivalent fractions. All right, cool. So that's questions 1 through 6, and then 7 and 8 are kind of like bigger multi-step problems. Question 7. The cost to enter and go on rides at a local water park, Wally's Water World, is shown below. So this, I'm going to label this, this is Wally's Water World. That's in the graph. A new park, Tony's Tidal Takeover, just opened. You have not heard anything specific about how much it costs to go to this park, but some of your friends have told you what they spent. The information is organized in the table below. So this is Tony's. Each park charges a different admission fee and a different fee per ride, but the cost of each ride remains the same. If you only have $16 to spend, which park would you attend? Assume that the rides are the same quality. So again, we're having this idea where you have some fee to get into the park, but then you have to pay each ride. So the different admission fee, that is my initial value. Okay, and then a different fee per ride, that's my rate of change. So these are both linear functions. And we want to figure out if we have $16 to spend, which one's going to be better. So I want to be very clear. There are a ton of ways to approach this problem. So you could like extend the tables. You could create a table for the graph. You could create a graph for the table. You could create an equation for both. Like so many different ways to approach it. So I'm going to do my best to go over all of them quickly, but any of these ideas would work. Okay, so for Wally's, we can see that for Wally, the initial value is $8. So you have to pay $8 to get into Wally's Park, because even if there's 0 rides, you still pay $8. And then we can find the slope or the rate of change by saying, okay, after I ride one ride, my total cost has gone up from $8 to $10. So I had to pay $2 per one ride. Okay, so there, for Wally's, $2 per ride. I'm going to do the same thing because it'll be helpful later for Tony's. Okay, my initial value for Tony's, I have to pay $12 to get into the park, because that's what 0 rides, I still have to pay $12. And then I can find the slope. For 2 rides, my cost goes up $1.50. So I can do $1.50 divided by 2 rides, and that's going to be a rate of change or a slope of 75 cents per ride. So this is my equation for Tony's, and this is my equation for Wally's. So if I have $16 to spend, I want to figure out, right, how many rides can I go? So, right, how do I do that? Lots of options. Like, for I think a lot of you, making a table would be easier than doing it the algebraic way that feels easier to me. So I'm going to help us with the table first, but then I'm going to write the algebraic way here. So for Wally's, 0 rides, $8. 1 ride, $10. 2 rides, $12. 3 rides is going to be $14 because it's going up by 2. 4 rides, $16. So for Wally, okay, you can ride 4 rides for $16 at Wally's. Okay, then I can look at this table that I have for Tony's. I see if 6 rides, it's $16.50. So then I want to consider it for 4 rides, it's $15. So I can't, for $16, I can't quite afford 6 rides. But can I afford 5? So I can consider this table, think about, okay, 4 rides is $15, so 5 rides is going to be $15.75 because I am adding the 75 cents to the 15 rides.
Yeah. Okay. That's so funny.
Okay, so it costs $15.75 to ride 5 rides at Tony's. So that means I'm going to be able to get 5 rides at Tony's. So you can ride 5 rides for $16 at Tony's and have 25 cents left over. Thus, therefore, what would we rather do? Would we rather ride 4 rides or 5 rides? We'd rather ride 5. So, thus, I would rather attend Tony's. Okay, so that is a perfectly good way of solving this problem. You can kind of like create these tables, extend the graph, see the pattern. Another way of doing this, though, is we can use these equations that I created. So for Wally's, we have y equals 2x plus 8 for how much you spend. And we're saying, okay, we spend $16. So 16 equals 2 times x plus 8. I can solve this equation to figure out how many rides that you can get at Wally's. Subtract 8 from both sides because I'm adding 8. I get $8 equals 2 times x. Divide by 2. X equals 4. So again, that's the 4 rides for $16 at Wally's. And I could do the same thing at Tony's, except my equation is y equals 0.75x plus 12. Need to make 16 my y. That's how much money I have. Solve this equation to figure out x, how many rides I can spend. Subtract 12 on both sides. 4 equals 0.75 times x. Divide by 0.75. This would be 5 1/3 rides. So they're saying for $16 you could get 5 1/3 rides. You don't have enough money for 6 rides, but you do get to go on 5 rides. So again, you can figure it out that way. Okay. Again, it's totally up to you which you prefer of those methods, right? Or any other method, as long as we can figure out this data about 4 rides at Wally's for 5 for Tony's. Okay, we've already done so much work and we're still only on part B. Part B. Another water park, Splash, opens and they charge an admission fee of $35 with no additional fee for rides. So you pay $35, you can ride any ride as much as you want. At what number of rides does it become more expensive to go to Wally's Water World than to Splash? Okay, so we go back to our Wally's situation. Our equation for Wally's is 2x, y equals 2 times x plus 8. $8 to get into the park, $2 per ride. And we want to figure out, when is that more expensive than Splash? So Splash costs $35, one-time fee. It's all you have to pay. So we can say, okay, when is this, how much money we have to pay at Wally's, when is that equal to $35? Now, again, you could do this by making this table and extending it until you get $35 or more than $35. Totally fine. If you want to do it that way, you can do it that way. But in this case, it's definitely going to be easier to do it algebraically. So we have this set up and we solve this equation. We have plus 8. We can get rid of that plus 8 by subtracting 8 on both sides. 27 is equal to 2x. X is being multiplied by 2. Undo that by dividing by 2. And 27 divided by 2 is 13.5. So that means after 13.5 rides, the costs of Splash and Wally's are the same. Now, we can't actually do 13.5 rides. So Wally's is getting more expensive at 14 rides. Wally's is cheaper at 13 rides. If you do 2 times 13, you'll get 26. Plus 8 is 34. So Wally's is cheaper if they go on 13 rides. But Splash is cheaper once you go on 14 rides, because then the cost of Wally's is more than $35. Okay, so at 14 rides, it is more expensive to go to Wally's. And again, many ways you could figure that out. As long as you figure it out some way, you would receive full credit. Okay. Finally, C, for all 3 water parks, the cost is a function of the number of rides. So if we input the number of rides, we're going to output the cost. Compare the functions for all 3 water parks in terms of their rate of change. What does the rate of change mean in the context of these water parks? So Wally's, the rate of change is 2, which means each ride costs $2. Tony's, the rate of change is 0.75. Each ride costs 75 cents. So then we think about Splash. All we're told about Splash is that they charge an admission fee of $35 and there's no additional fee for rides. So how much does Splash charge per ride? $0, nothing. You have to pay $35 to get in, so there's a very big initial value, but the rate of change is $0 per ride. Okay, it's going to be a constant function. The graph would be a horizontal line. So we have all 3 of their rates of change, and what does the rate of change mean in the context of these water parks, right? So it's the cost per ride. So Wally's costs the most per ride. Tony's is the second most per ride, and Splash is free per ride. So I'm going to write a sentence that says that. All right, so there we go. The rate of change is the cost per ride. At Wally's, the cost is $2 per ride, the most expensive. Tony's cost is 75 cents per ride, and each ride is free, costs $0 at Splash. And again, Splash isn't free. You have to pay $35 to get into the park. but how many rides you go on doesn't matter. So it's not changing based on the number of rides you go on. All right, 7 is a hefty problem. Okay, getting a +4 in this problem will be a challenge, but I'm sure you can do it. I didn't change it, like, I very, very minimally changed this problem. So make sure you understand this problem. It'll be a question super similar, more than similar to other questions on the test like this. Question 8. 2 lawn mowing companies charge money for each hour of work plus a one-time fee. So that each hour of work, how much they get paid per hour, that's going to be our rate of change. And the one-time fee is going to be the initial value. So we have 2 linear functions here. We have A plus mowing charges according to this table. Quality mowing charges according to this graph. And we're trying to figure out how much does A plus mowing cost for each hour of work and what's the one-time fee. Same for quality mowing. And then considering whether they can ever charge the same total for the same amount of time. For A plus mowing, we want to find the cost per hour of work. Okay, so to do that, we can see, okay, what is the change from $80 to $120? That's a change of $40. And then from 1 hour to 3 hours, that's a change of 2 hours. So for A plus mowing, they get paid $40 for 2 hours of work. So that means they're getting paid $20 per hour. And we can check this here as well. Here we're working for 4 hours, and they get paid $80. $80 divided by 4 hours is also $20 per hour. Okay, so that is the cost per hour of work. And then we also want to figure out the one-time fee. Now this is tricky because we're not given 0 hours in the table. So normally to find the initial value, we just, like we did here, we find the output when the input is 0. Okay, but we can't do that in this case because they don't give us that. So what we have to do is we have to work backwards. We know that, we know that 1 hour of work is $80 and that they charge $20 per hour. So if we think about this in a table, right? If this was 0, this is 1. We know 1 is 80. And we just found that in 1 hour, it's a cost of $20. So then 0 hours must cost $60. Because we can just go back $20 because it's $20 per hour. Okay, so that is going to be my one-time fee is $60 and it's $20 per hour. Okay, and then we can write something like this. A plus mowing charges $20 for each hour of work. The one-time fee is $60 and my work is shown up here. Now we're going to do the same thing, but we have a graph for quality mowing. So we can find the one-time fee, my initial value, pretty easily from a graph. We just look and see at 0 hours, what's the cost? Okay, so we can clearly see here the y-intercept is $50. And then to find the cost per hour of work, our rate of change, we can find the slope. So we can pick 2 points on the line and find the vertical change divided by the horizontal change. So in this case, horizontally, we're going from 0 hours to 5 hours. So this is 5 hours. And we're going from $50 to $100. So that's a change of $50. So the slope, or the rate of change, $50 for 5 hours of work. That means they get $10 per hour. Okay, and finally for question C, we really need to think about this. Okay, can A plus mowing and quality mowing ever charge the same total for the same amount of time? So are they ever going to charge the same amount of money? So in this situation, quality mowing is cheaper to start. So 0 hours, they charge $50. And A plus mowing is $60, more expensive to start. And then quality mowing is charging $10 per hour. That's less money. And A plus mowing is charging $20 per hour. So are they ever going to charge the same amount? They are never going to charge the same amount because A plus mowing has a more expensive one-time fee and it's more expensive for each hour of work. Quality mowing is cheaper, both in terms of the one-time fee and in terms of the cost per hour. So quality mowing is always going to be cheaper. Another situation where they're never going to charge the same amount is if they have the same hourly rate. So like if they both cost $20 per hour, but one has a more expensive one-time fee, because then we'd have parallel lines and they'd never intersect. All right. There we go. That's everything. Good luck. Study hard.